Hey guys, welcome back to another one. So here I'll be going through the complete walkthrough of the paper 1 non-calculator, which is actually the first official paper released under the 921 GCSE. And this one was actually one of the hardest. Well, paper 2 was ranked, even made headlines in the news. So let's have a look. And just a keynote, make sure an exam that you use black ink or else your work will not get scanned properly and might cause issues. And of course, calculators may not be used. So everything here will be calculated mentally or using methods. So without further ado, let's go. So number 1, what do we have? So the scatter graph shows the maximum temperature and the number of hours sunshine in 14 British towns on one day, which is usually expected to be low. So here we go. So far it seems to be like a positive correlation, as the number of hours of sunshine increases, or at least then the temperature will also increase, or vice versa. And one outlier seems to be here. So one of the points is an outlier, right down the corners of this point. So like I said, it's over here. So this looks like it's going bang in the middle between 9 and 11. So it's 10 across and 19 up. So the answer should be 10 and 19. Okay. Now for all the points, write down the type of correlation. Well, this is 100% positive because, well, everything's increasing together. So that's what you just write, positive. C. Now on the same day in another British town, the maximum temperature was 16.4 degrees Celsius. Estimate the number of hours sunshine in this town on this day. Now the key thing here is that it's always best to draw a line of best fit. Unfortunately, I'm not using PowerPoint, so it'll be a bit tricky, but make sure you have a ruler and try and draw a nice line that cuts through everything here. God, this is going to be quite awful. And when you do that, well, you should get the following. You should then look for the exact value, 16.4, and it cuts somewhere around here. Thankfully, the examiner will give you like a big leeway. So this is the 16.4 mark, about here. Because we can see it's going up in 2 blocks. And you just drag it all the way down. And you realize it cuts somewhere around here. So you can have any answers literally between this interval. I'm going with about 12.8. Fine, that's the thing. So about 12.8 hours. Okay. Now let's move on. So a weatherman decides to say temperatures are higher on days when there is more sunshine. Well, to be honest, looking at this graph is true, because as the number of hours increase, the maximum temperature or the temperature itself also increases. So does the scatter graph support what the weatherman says? And here you can just simply say yes. Pretty much just talk about the temperature itself. So yes. So as temperature increases, then therefore there is more sunshine. You can also say the fact that you're using a positive correlation, yeah, which indicates, that pretty much sums it up. So there's various ways to answer, but try and be as clear as possible, and it's quite an obvious statement, I think. Anyway, next one, number 2. Right, what do we have here? So express 56 as a product of its prime factors. Okay, so what do we have? So first things first is firstly write down 56 and then just use a factor tree method and start breaking it apart. So one thing about 56, we know that it's even number, so break into 2, so it'll be 2 times 28. That's the first thing. Break down 28 is 2 and 14. Break down 14 is 2 and 7. And that's it. It should be this. And your prime factors, you always circle the prime numbers only. So how many 2s we got? We've got 3 2s, so it'll be 2 to the power 3. And you got single 7. And that's it. That literally equals 56. Whew, so easy so far. Now, number 3. Work out 54.6 times 4.3. Well, imagine this. When you got decimals, ignore decimal and literally get straight to it. And rewrite this as 546 times 43. Now, you can use various methods. Column or block method, row method. I mean, I'm sure there's like, your name has probably come up as a method too. What I would personally do, I just use the column method because it's standard. And it works for me. For other people, they might prefer the block method. Your choice. And what I do, I always split this in 2 parts. So I got 546 times 3 and 546 times 40, just for the sake of avoiding a very popular error. Now working out each one, let's do it. So we've got 6 times 3 is 18, carry the 1. 4 times 3 is 12, plus 1 is 13, so 3 and 1. And then 5 times 3 is 15, plus 1, 16. So that's one answer. Now, when you're multiplying by 40, you can just stick a 0 in because it's like times in my 10 too. So let's do it. So 4 times 6 is 24, so 4, carry the 2. 4 times 4 is 16, plus 2 is 18, carry the 1. And then 5 times 4 is 20, plus 1, 21. Okay, now all we do here is simply add them up now. So just be very careful when you add up the solutions. So let's see. So we can say, therefore, this solution plus 1638. So I'm going to put this underneath. 1638 plus. Now adding them up, you just simply going to get 8, 7. 8 plus 6 is 14, so 4 carry the 1. 1 plus 1 plus 1 is 3, and 2. And by the way, looks like we're done here, but we're not. Now we really got to think about the decimal place. So if the decimal place is moved 1 across here and 1 across here, we can say collectively it's moved a total of 2. 1 plus 1 is 2, yeah? So just add up how many places it's moved for each numbers. Sometimes if the decimal is here, it will be 2 places. So it will be 2 plus 1, 3, and so on. So that means if it's moved 2 places, then it must be here. Another way to think about is just think about what would 54 times 4 be, or better yet, 50 times 4. That's 200. So it's 3 numbers. So we're expecting something along the line. So 234 is a safe answer. Anyway, moving on. Number 4, oof, algebra, I love it. So you're given some information, and it states that the area of the shape ABCD equals 10. So the total area is 10. Keep that in mind. Show that you can make a quadratic equation. Right. So literally just find area of each block and equal it to 10. So let's do it. And they've done it easy for us. So 3 times 3 here is 9 centimeters squared. 3 times x is 3x. And we got x times 3 is, again, 3x. And then x times x is x squared. Now just add them all up and equate it to 10. So let's do that. So we can say, therefore, x squared plus 3x and 3x is 6x plus 9 equals 10. And now just get the form they want. So throw the 9 across to the right hand side. And we should that basically means subtracting 9, so we should get 1. And that's it. Case closed. Okay. All right, so let's move on. Number 5. So this rectangular frame is made from 5 straight pieces of metal. Oof. I mean, just looking at it head on, this looks like a Pythagoras' theorem. Okay. So the weight of the metal is 1.5 kilograms per meter. So every meter, so whatever your final result, times it by 1.5. Work out the total weight. Okay, that's fine. So total weight would literally be 1.5 times your answer. So that's what we're going for. Now, how to do this? Well, first things first, this is a right angle triangle, so using Pythagoras, we can work out this diagonal side. So just whip our triangle here. Call this one 5 and 12. Call this one h, hypotenuse. So using the a squared plus b squared equals c squared method, i.e. Pythagoras, and where a and b are the short sides, we can say now that 5 squared plus 12 squared must equal c squared, which is h squared. And we just solve it. So 5 squared is firstly 25, so just be comfortable with your square numbers, guys. 12 squared is 144. And now, tidying this up, you should get 169. So for those who don't know, I highly recommend that you memorize your square numbers up to 15. Reason why? Because we need to firstly recognize that 169 is actually 13 squared. So h itself is 13. 13 squared is this, so definitely keep that in mind. So because we got h, we know this is 13. We also know that this is 5 and the opposite length is also 12 because it's a rectangle. And alas, now we just add everything up. So 5 plus 5 is 10. 12 and 12 is 24. Plus 13. We should be quick at maths. So 10, 24, and 13. This gives 37, 47. So the answer would be, total weight would be 1.5 times 47. Again, using any method, well, I just split this up. As I always do this as 1 times 47, which is 47, and then 0.5 times 47, which is actually same as half of 47, which is actually half of 20 is 20, 40 is 20, and this is 3.5, so 23.5. And then add them together and you get 70.5. So whatever works for you guys, yeah? Kilograms. Right, not bad. Let's move forward. Number 6. So the equation of a line L1 is given by this. Second line is given by another type of linear equation. Show that these two lines are parallel. Oof. To show something is parallel, we need to firstly make sure everything is in the standard form, and then basically guarantee that both of these have the same value m, the same gradient. Now looking at the first line, it's already set out for us. The gradient here is 3, so m is 3 for line 1. Now for the second equation, yeah, just rewrite into this form. So let's just get down. So this is for line 2, yes. Always definitely make it work clear. Now what we could do is literally throw everything that isn't y to the right hand side. So minus 9x plus 5 is thrown to the right, and they change sign, so they become positive 9x and negative 5. And lastly, to get into this y form, divide the equation by 3. So you should get y equals 3x. 5 divided by 3, well, doesn't matter, 5 over 3. And yes, they have the same gradient because they both have a 3. So you just stay parallel since m equals 3 for both lines, indicating they're parallel. They just have a different y-intercept, at minus 2 and minus 5/3. Yeah, that's it. Alright, number 7. So now, what do we have? So there are 10 boys and 20 girls in a class. The class has a test. Now the average mark for all the class is 60, whereas the mean mark for the girls is 54. Oof. Work out the mean mark for the boys. Very easy way to do this. First things first, we need to use the weighted mean technique. This just means that we're finding the average of the average. So let's have a look. We have 10 boys and 30 girls in class, meaning the total mean would be over 30. For the 10 boys, well, we're trying to find the mean mark. So let's call the mean mark for boys x. For the girls, we know the mean mark is 54. So it'll be 20 times 54. And we know that the total mean mark for the whole class is 60. So it equals 60. We begin here. Now you just solve and find x. So let's see. What we could do is times 30 across. So we're going to have 10x plus, and multiplying this out, you can do 2 times 54 is 108. Add a 0, 108 with a 0. 6 times 3 is 18, add 2 zeros. So that's just some mental maths there, yeah? Now, you just have to solve and rearrange. So what you could do, make your life easy. Actually, to make it super easy, divide the whole equation by 10. So you're left with x plus 108 equals 180. Now you just subtract 108 and get 72. And that's it, guys. The mean mark for the boys is 72. Okay, question 8, guys. Let's have a look. So A, write 7.97 times 10 to the power negative 6 as an ordinary number. Okay, so all this literally means, super easy actually. When you got a negative power and a 10th base, this is known as the standard form, even positive. The key idea is that you just want to put 6 digits behind this, and that's it. By 6 digits, you just rewrite it as 6 zeros. So it'd be 1, 2, 3, 4, 5, 6. And that's it. And then you just put 797 and smash the decimal point here. There's other ways to do this, but I always think of negative 6 as 6 numbers behind the 7. Okay? And that's really it. So this will be your final answer. So you just put that over here. Okay? B, work out the value of 2.52 times 10 to the power 5 divided by 4 times 10 to the power negative 3. Again, standard form. Now, there's two ways to do this. One, you could expand it, or you can use a nice trick, and that is taking advantage of the powers. So first things first, write the whole equation, and because you're dividing, write it as a fraction. So it'll be over 4 times 10 to the negative 3. Okay, so now looking at this one, firstly look at the tens. We have 10 to the power 5 over 10 to the power negative 3. When you're dividing terms, you're subtracting the power. So it'll be 5 minus 3, which is the same as 5 plus 3. So the solution will be 10 to the power 8. So it'll be 8 up here. And then this cancels out. So we've got 2.52 times 10 to the power 8 over 4 now. Now we can just ignore this bit. In fact, you know what? Just to make your life a lot easier, you can split them in two terms. So it'd be 2.52 over 4 times 10 to the power 8. So this bit is done. Now we just got divided by 4. So literally just use any division method. I'm going to use the classic bus stop method, you know, the ones you learn probably back in primary school or early on. So what do we have? So we go 4 into 2, we cannot do. It goes 0 times, carry the 2. 4 into 25 goes exactly 6 times, it goes to 24, remainder 1, and 4 into 12 goes 3. So alas, we now have 0.63 times 10 to the power 8. Unfortunately, you cannot keep this as your answer because it's not standard form. The unit part here must be between 1, it should be 1 to 9. So we need to kind of shift the decimal place here. So the way I see this, if you move the decimal place across, so you expand this number, you must decrease the power. So it'll be 6.3 times 10 to the power 7. Okay, that's really it. That's all you have to do at this stage. Anyway, let's move forward, guys. I think we're good. Number 9. So Jules buys a washing machine. 20% VAT is added to the price of the washing machine. Jules then has to pay a total of £600. What is the price of the washing machine with no VAT added? So in other words, this is like a compound percentage problem. The way I use this, I use something known as the present or original value. That is, you can say that the original value times some multiplier must give you a new value. This is a very popular formula. So we just look at what's what. If we're increasing, it will be plus R. If we're decreasing, it will be negative R. As we're adding to the VAT, it will be plus 20%. So 1 plus 20%. Okay, and this means, and the new value we got was 600. So we're just calculating the old value. Okay, so that's it. And now we just solve this one. So what you could do, if you just expand this, or you can just make OV the subject, you can say OV equals 600 divided by 1 plus 20%, which is 1.2. And now you just fix that up, and you're done. So to scale this one properly, without a calculator, unfortunately, you just have to clear the decimal. So times up and down by powers of 10, so times it by 10, and you should get 6,000 over 12. Now you just simplify the fraction. So dividing by 2, you get 3,000 over 6. Half again, you get 1,500 over 3. Dividing by 3, you get 500. Done. Very easy. Other methods are possible, but always start with this unique formula and then just work your way to the end. Alright, number 10. Show that this triple bracket can be written in this form. Oh, so easy. Just expand, guys. So I always start with the last two, just for the sake of simplicity. So expanding the last two brackets, just use a FOIL, so do x times x times 3, 2 times x, and 2 times 3. Let's do it. So x times x is x squared, x times 3 is 3x, and 2 times x is 2x. That gives you a total of 5x. And lastly, 2 times 3 is 6. Now, as we're trying to solve this last bit, there's a cool way to present this. Again, let's open up the brackets. So I'm going to change pen. And we can say x times x squared, x times 5x, and x times 6. So call this one the extended FOIL. And do the same with 1, guys. Literally just attach it everywhere. So, and follow this step carefully, yeah? So firstly, let's multiply everything by x. So you're going to get now x cubed plus 5x squared plus 6x. Now, times everything by 1. So 1 times all that. And make sure you line up the powers, yeah? So 1 times x squared is x squared. 1 times 5x is plus 5x. And the other one be plus 6. And then just do a big line. Total this up and press add. Now you just total it up. So you got x cubed makes x cubed. 5x squared and x squared makes 6x squares. 6x and 5x is 11x. And we got 6. And that is your final answer. So easy, really. Whew. So we're in number 11 now. Now, question 11. So the graph of y equals fx is drawn on the grid, which is clearly a quadratic equation, by the way, with a turning point at 1 minus 3. And let me guess, write down the coordinates of the turning point. Well, it's right there. So 1 and negative 3. Okay. Write down estimates for the roots of when the function equals 0. So this means when this equation equals 0 and y equals 0, which is literally the x-axis line. So that's literally over here. So this is one solution and one solution. Now, you just have to be very careful. I'm probably going to zoom in for this one. So here, this looks like, the red line is kind of disruptive, I guess. This looks like it cuts the axis bang in the center between 2.5 and 3, so 2.75, I guess. And this one seems to cut between minus 0.5, minus 1, so minus 0.75. Just take your time and really analyze it, yeah? So you can say minus 0.75 and 2.75. Okay, let me zoom back out again. Now, so far easy. So use the graph to find estimate for the function when x equals 1.5. So notice how x is just being replaced with 1.5. So let's have a look. Where is x equals 1.5? Well, it's there. This is 1.5. So just see when it hits the curve. Well, it hits the curve at this point here. And that seems remarkably over here. So again, zooming in. And that looks like, ooh, so I think it's going up in 0.2s actually. So 2.2, 2.4, 6, 8. So this is negative 2.8. Yeah, well, I'm kind of surprised. This is quite a nice paper actually. Not so bad. Anyway, moving forward once more. Ooh, powers, indices. Yeah, I kind of like this, guys. So number 12, find the value of 81 to the power negative half. All right. So first rule, before you even do powers, when you have a negative power, don't think this is a negative solution, because it's not. It literally means a reciprocal, so it means 1 over the solution. So whatever your answer is 1 over. So we can quickly say 81 to the negative half is 1 over 81 to the power of half. That's it. Another thing, when you have powers of half, this is literally the opposite of squaring, which is, and the opposite of squaring is, well, square rooting. That's why we have half instead of 2. So square root of 81 is just 9. So the final value would be 1 over 9. Technically, it can be plus minus 9, but it just says find the value. So they probably didn't think about the negative 9 bit. Okay, or you can actually. To be fair, I'll still keep as plus minus. Why not? B. Find the value of 64 over 125 all to the power 2/3. Well, this is similar. Firstly, the 2 here represents squaring, and the 3 here represents cube rooting. My personal advice, do the cube rooting first, because nobody wants to find 64 times 64 and so on. So let's find the cube root of both numbers, yeah? So we can partition this, find the cube root first, and then afterwards square your final result. So the cube root is 64. If you don't know your cube numbers, just start from 1. So you have 1 cube is 1, 2 cube is 8, 3 cube is 27. I'm just going to guess the next one must be 64. The way these papers work is that they usually use numbers which are whole. They won't give you horrible decimals. They'll give you a whole integer. So the fourth cube number is, well, 4. And this one I'm guessing is also 125, because 5 cube is 125. So the cube root of this is 5. And lastly, guys, just square. Squaring both of these numbers will give you 16 over 25. Very easy. Number 13. So now what do we have here? So apparently the table shows a set of values for x and y. Okay. Alright, so for when x is 1, y is 9. And yeah, it seems to be increasing linearly, but this is decreasing in, well, God knows what. Probably inversely or something. Let's have a read. So y is inversely proportional to square x. Alright, so this is kind of those proportional questions. This literally means that y, firstly, is proportional to the inverse of x squared. So 1 over x squared. That's how we begin it. And the way this proportional sign works is that we just literally, this just works as a scale factor. So we can say, alright, y must equal some scale factor k over that. So it'll be k over x squared. Basically, to summarize, replace the proportional sign with equals k. And you're done. Now, this is easy. Find an equation for y in terms of x. Well, y in terms of x, we never said y in terms of k and x. So we need to somehow replace the k and just plug in some values for y and x from the table and find k. I'm going to go ahead and use 3 and 1 because it looks easy. You could use 1 and 9. Do not bother using 2 and 4 because that's horrible. So when x is 3 and y is 1, the equation becomes 1 equals, actually I'm a bit silly here, aren't I? I could use the very first one. When x is 1, y is 9, because then we have 9 equals k over 1 squared, which is k. So we found the answer. So the solution would be y equals 9 over x squared. Yeah, easy. Now, find the positive value of x when y is 16. Again, plug in 16 for y and solve for x. So we've got 16 equals 9 over x squared. Swap the positions because you can multiply x squared across to by 16. So we have x squared equals 9 over 16. And alas, to get rid of the square, well, square root. So the square root of both of these numbers is 3 over 4. Usually plus minus, but the question says positive value, so plus only. So yeah, so far so good, isn't it? Right, this one I heard infamous stories about. This is definitely one of the trickiest questions, but trust me, secretly it's easy. Let's have a look. So white shapes and black shapes are used in a game. Some of the shapes are circles, whereas every single else are squares. The ratio of the number of white to black shapes is 3 to 7. So before we even move on, let's put 3 to 7 here, and let's call this white and black shapes, yeah? So we have a total of 10 parts, but we'll get to that. Or we can also say 3/10 are white and 7/10 are black. Why? Because the total part is 10 and 3 out of 10 parts is white, 7 out of 10 parts is black. Next one. The ratio of the number of white circles to white squares, so this is within the white column, is 4 to 5. So ultimately we can say for the circles, if the total number of parts is 9, so we can say 4 9s are circles. So 4 9s are circles, whereas 5 9s are squares. The reason why I'm writing this now, because it's best to summarize information before you solve the question. And the last one, the ratio of the number of black circles to number of black squares is 2 to 5. Again, the total number of parts is 7. So we can say 2 7s are black circles, 5 7s are black squares. So let's do over here. So from 7/10 we can say 2 7s are circles and 5 7s are squares. It doesn't matter how you write this, best to write it somehow. Now here comes the ultimatum. Work out what fraction of all shapes are circles. Let's have a look. Firstly, we know that of the white parts, 4/7 of the 3 white parts, i.e. 3/10 are circles. Let's write it down. So circles. From the white section, 4 9s of 3/10 are circles. We also know from the black section that 2 7s of 7/10, 2 7s of the 7 parts, i.e. 7/10 are circles too. So let me write it down. So 2 7s of 7/10 are also circles. So ultimately, solve this and, well, that should give you an answer. And that's it, we add them up. So 4 over 9 of 3/10, you just multiply. So change the off sign to time sign, guys. So I will just delete this, change my color pen to purple and put times. Now, we're pretty much done here actually. So to solve this very intuitively, you could multiply head on or you could simplify. Well, when I look at these numbers, I can see that 3 and 9, when I cross simplify, are both in the 3 times table. So divide them by 3, you get 1 and 3. Divide 4 and 10 by 2, you get 2 and 5. Same thing below. 2 and 10 divide them by 2, you get 1 and 5. 7 and 7 divided by 7, you get 1 and 1. And we're done. So now we decide to multiply. Trust me, it'll help you from wasting time, literally. So multiplying cross, 2 times 1 is 2, 3 times 5 is 15. Second one, you should get 1/5. And now we have to add them up. So convert the second one to make it over 15 because it makes life easy. Times up and down by 3, and you get 3. Add these two, and you get a total of 5 over 15, or, wait for it, 1/3. Voila. So 1/3 are circles, clearly 2/3 are squares, but we just care about circles. Yeah, so definitely see how it's to double check this question. This was a hard ratio question, or easy, I don't know. Yeah, have a go. All right, number 15. So a cone has a volume of 98 centimeter cube, and they're kind enough to give you the formula too. The radius of the cone is 5.13. Cool. Work out an estimate for the height of the cone. Thank God we didn't have to actually work that out. So the volume of the cone, or for the height, okay, let's write the general formula first. The volume is going to be firstly 98 and the radius 5.13. So popping in the formula, we've got 1 over 3 pi radius, which is what, 5.13 squared, and height we do not know, and volume we do know is 98. Now to estimate this, well, you just have to round this up neatly, and we have to firstly assume that pi is 3.14. Keep it like that. So estimating, well, let's have a look. Let's round it all to, let's say, one significant figure. So 98 rounds up to 100 because it's close. 1/3 is kind of okay. Pi is can be rounded down to 3. So 1/3 times 3. So 3 over 3 is 1. So these two cancel out. Now 5.13, that can be rounded down to 5. So 5 squared is 25. And at last we got h. So now you just solve. Divide 25 across and you got h, which is 100 over 25, which is exactly 4 times. So we can estimate the height of the cone, which is 4. Not bad. Now, John uses a calculator to work out the height of the cone, which I did as well too, by the way. Will your estimate be more than John's answer or less? Well, it's actually very easy to know. There's a trick when it comes to fractions. If we rewrote this entire equation using what we had earlier, the actual height would be, using the original formula, 98 over all of these, which is 1/3 times pi times 5.13 squared. Now, one thing to note, if you look carefully, the top fraction is lower for the true value, and the bottom fraction is heavier. This means that the ratio between them is tighter. So if the gap is smaller, we're going to get a smaller answer. The estimate has a wider gap, so we're going to get a bigger answer. So in fact, our estimate is actually bigger. And well, my reasons is literally that. You can just say because the numerator is heavier, so numerator is bigger, 100 bigger than 98, and the denominator, so I'll try dom, is smaller, since 25 is less than, well, we're going to assume pi over 3 times 5.13 squared, definitely. So there's a lower gap. The gap is smaller for the true answer, but the estimate is bigger gap. That's it really. And you can use this for any fraction question, by the way, guys, so keep note of that. Okay, number 16. So n is an integer greater than 1. All right, cool. Prove algebraically that this equation, which looks kind of mad, is always an even number. Well, I mean, I can tell you straight away what it is. An even number is something that's divisible by 2 or can be factorized as 2 times something. This is literally the result. We need to pretty much factorize 2 out of the equation, and wherever the something is, doesn't matter, as long as you got 2 outside. So let's do it. Let's solve and expand. So expanding this entire expression, we're going to have firstly the first two, n squared minus 2. Expanding the bracket here, we're going to get n squared minus 4n plus 4. If you're not sure why I did that, this is just 2 brackets, n minus 2, n minus 2. Expanding this, you should get the same conclusion. Okay. Now, be very careful when you subtract, yeah? Because this minus sign will flip everything here. So just expanding it carefully, we're going to have minus n squared plus 4n minus 4. Good. So now we're out of that risky area. So now let's go ahead and simplify. So n squared and minus n squared cancel out, so get rid of them. And you're left with minus 2 plus 4n minus 4. So put it in correct form, we can say we have 4n and minus 2 minus 4 make minus 6. And we're done. Or we just factorize 2 out of that, so we get 2 times. Yep, my screen's messed up. Okay, now it's working. So factorizing, you should get 2n minus 3. And yep, even, because of this assumption. That's it. Moving on. Alright, number 17. Okay, it's too high up the camera. So, there are 9 counters in a bag. 7 are green, 2 are blue. Okay, so that's fine. Ria takes at random 2 counters from the bag and probably doesn't return it. Work out the probability that Ria takes 1 counter of each color. You must show you're working. It's very straightforward. So you just got to think of the colors. So if one of each color means she could have taken the green first then a blue, or she could have taken a blue first then a green. And you just find probabilities of both. So probability of taking the green counter first, well, it's 7 out of 9. Now because she's taken 1, she's got 8 left. And taking the blue, well, there's 2. Likewise, if you take a blue first, it's 2 over 9. You got 8 left. And taking a green, you got 7 at the moment. And you're done. And now you just evaluate and you just total up the probability and you get all that space to figure that bit out. So 7 times 2, which is, oh, actually you can simplify the fraction. Always simplify first, guys, yeah? So, with my pen. So cancelling down 2 over 8, you get 1 over 4. So 1 over 4. And again, cross multiplying, cross simplifying here, you get 1 over 4. And you just add them up now. So 2 times 7, 2 times 1 is 7. 9 times 4 is 36. And this will probably give you the same result. And thanks to the law of total probability, we just add up the final result, which will give us 14 out of 36. Done. Very, very easy question. Okay, question 18, guys. So what do we have? So it says ABCD is a rhombus. Okay, so rhombus is practically a parallelogram with perfect lengths. Now the coordinates of A are 5, 11. So here is 5, 11. So let me just write that down here. The equation of the diagonal DB, so D to B, is given by this equation, y equals half x plus 6. So what I would do is firstly draw a straight line. And there you go, call it y equals half x plus 6. Find an equation of the diagonal AC. Oof. So we want to find this diagonal now. Now, sometimes it's either obvious or you need to memorize the property, but one thing to know is that the diagonal in a rhombus are perpendiculars with each other. So both diagonals are perpendicular, okay, due to their lengths being the same and whatnot. Anyway, let's have a look. So because it's diagonal, what does it actually mean? Well, first things first, this means that the equation of the line have perpendicular gradients, meaning the gradients are just very similar, just reciprocate with a change of sign. So for example, we know that the gradient of this line is a half, right? This automatically means that due to perpendicular lines, the gradient is now upside down and the sign changes. So it means it's 2 over 1 with a negative sign, positive negative, which is literally minus 2. Yeah, and that's all it is. So thus so far, our equation for that red line is minus 2x plus c. And thankfully, well, we're almost there. All we need to do is figure out any coordinates on this point, on this line, and find the value c. But thankfully, we have one. It's 5, 11. We just plug in the values of 5 for x and 11 for y, and so for c. And yeah, that's it, guys. That's literally all you do. So to make this clear, we just say at point A, or at 5, 11, we can say this equation becomes now, so y becomes 11, and x becomes 5, so minus 2 times 5, which is minus 10, plus c. And solving this one, plus and 10 across, you get c, which is 21. And we solved it, guys. We're literally done. So the equation is now, therefore, the equation of the diagonal is y equals minus 2x plus 21. Done. Very easy, really. Okay, almost done, guys. Number 19. Oof, vectors. I love vectors. Okay, so OABC is a parallelogram, okay? Now, this see the difference between these two is that rhombus have the same lengths, is a parallelogram with same lengths all around, and a parallelogram, of course, only has same lengths which are opposite. So, since we know that the vector here is little a, this means this is also little a. Because the way vectors work, if you move in the same direction and have the same size, you're practically the same. Likewise, OC, this is a vector C. That means above it would have parallel vector of C as well. Anyway, what else do we know? So X is the midpoint of the line AC. So, oh, great. So more lines. So draw another dot line. And call this one point X. OCD, I love that, is a straight line so that O to C and C to some imaginary D. So extend this line across. Is k to 1, so let's call this point D. So what does this mean by this ratio fraction? Suppose it said 2 to 1. This means that if it said 2 to 1, this would mean that O to C is twice the length of C to D. But what this means here is that O to C is K times bigger than C to D. This means that C to D is K times smaller. So we can say this vector is 1/k of C. Okay. If you haven't understood this, just write a comment below and we can discuss it. Okay, so far so good. Now, what do we need to know? It also tells us that the vector from x to d was d. So we're basically traveling from this point anywhere you want to d is given by this. Find the value k. All right, so what I would personally do is firstly find what x to d is in terms of what we have, and then equate it to this one and figure out k. Okay, so let's figure out what x to d is. So yeah, before we get x to d, let's find something that relates x. We can say straight away that because x is the midpoint, we can say if you're moving from, let's say, a to c, we can say that a to x actually is literally half the distance of a to c. So let's write it down. We can say going from a to x is literally half of a to c. Make sense? Let's go ahead and find a to c then. Well, going from a to c, you can go travel across this vector and go back. So it'll be plus c minus a. So it'll be c minus a. So that's literally the value of the vector. There's probably other variations, but this works fine. Now, what is the point of that? So now we can use this to get to d. So let's go from x to a to b, b to c, and d. So let's just travel all the way around to get to d, yeah? So we can say therefore x to d is going to be from x to a. So we know it's half c minus a, so it would just be the negative version. So it'll be minus half times c minus a. So this is the opposite side. Plus c minus a. So plus c minus a. And then plus 1/k of c. Plus 1/k of c. And yeah, now we just somehow tidy up. So let's collect everything in terms of c's and k's, c's and a's. So let's expand it. So we're going to have firstly minus half c plus half a plus c minus a plus 1/k c. Now collecting all your c terms, we have minus half plus 1c, which is 1/2c, plus 1/k. So we're going to have 1/2 plus 1/k c. As for a's, we have half a minus 1a, which is minus half a. So that's actually identical to the given that statement. Now, and that's pretty good actually. It means that we've pretty much found a perfect representation. We can see clearly that we've got minus half a minus half a. And we can actually realize that 3c must be equal to this quantity here because they're both xd's. So we can say all of these guys must equal 3. And yeah, now it's just a case of simple algebra. So now we just have to equate all that to 3. So we can say half plus 1/k equals 3. What I would do first is combine the fractions here, yeah? Oh, you know what? Let's get to that later. Let's just say half plus 1/k equals 3. Let's clear the fraction, yeah? Let's multiply k across. So we're going to have k/2 plus 1 equals 3k. Times 2 across, we're going to have k plus 2 equals 6k. And alas, now we just solve for k. So now subtracting k across, you're going to have 2 equals 5k. Divided by 5, you get 2/5 equals k. And yeah, and that should be the answer. K is 2/5. Oof, definitely one of the longest vector questions I've seen. So yeah, pretty good. All right, number 20, guys. Almost done. We literally got how many questions left? Yeah, I think this is it. I think 22 is the final question. So we're almost done. If you guys been watching so far, seriously, give yourself a pat in the back because you've been amazing. Now, let's wrap this up. So solve algebraically the simultaneous equations. Okay. A key strategy here is to always use the linear part of the equation and substitute into the quadratic part. That's really it. And what you should do is firstly make like something easy subject like y. I would make y the subject for the second equation. And it would look a bit like this. You would have to plus 3x across, so it would be 3x plus 13. This would be the key variable to substitute into the quadratic equation. Oh, yeah, I'm getting a bit tired now. So let's try and wrap this up. Since we know the value of y, which is 3x plus 13, that means the value of y squared is all of this term squared. So rewriting the first equation, we'll have now x squared plus the new variables 3x plus 13 squared and must all equal 25. And now we just go ahead and finish this off. So expanding the brackets, so we've got x squared plus, and remember, keynote, this means double brackets. Okay, so we're going to have 3x times 3x is 9x squared. 3x times 13 is 39, and another 39x, and that'll make 78x. And then 13 times 13 squared is 169. Must all equal 25. Oh, so yeah, the maths gets very intense, man. Unfortunately, that's what we have to do. Now let's solve this, yeah? So collecting like terms, x squared and 9x squared makes 10x squared. We've got 78x. 169 minus 25 is 144. All right, almost done. Can we simplify? Yes. Try and divide this. You can divide this all by 2. So we're going to have 5x squared back to 39x plus 72. So always try and find ways to make your life easier. Now, what can we do here? So, all right, so you could use a quadratic formula, which I do not recommend, because then you have a b value of 39 squared. Horrible. So let's try factorizing. So first things first, I would put 5x here and x, because this is the only possible way to make 5x squared, using integers obviously. Now we need to find the correct pairs to solve this. So we need two numbers to make 72. Let's think. To make 72, two numbers that multiply make 72. Well, we have 8 and 9. Yeah. What else do we have? We also have, let's think, 18, 4 and 18. Cool. Anything else? 72 is also divisible by 3, right? So yeah, 3 and 24. All right, now this is the challenge. So the way to solve this really easily is ask yourself, okay, these two numbers need to sum or subtract to make 39. In this case, everything's positive, so you're probably adding. And one of these numbers need to multiply by 5 to guarantee this term. So for example, I'm going to just choose the last one because I've actually done it previously, but the key idea is just to pick a term. So I'm going to pick this pair. I would multiply 3 by 5. Why? Because 3 times 5 is 15. And if you added 24, you get 39. So that's it. So it'll be 5 times 3, and 24 goes there. You can test for other values, but you won't get the right answer. If you times 4 by 5, you get 20. You can never make 39, and vice versa. Yeah. So anyway, getting back to the work. So therefore, this means x is minus 3, and 5x is minus 24. And which means x is minus 24 over 5. And of course, x is minus 3. All right, so almost done. So now we found the x values, and now we need to find the y values. So actually, this is easy. You just plug in the x values into this equation. So bring it down here. So y equals 3x plus 13. Is that, yep. So we can say firstly, when x is negative 3, because it's easy to work with. So when x is negative 3, y is going to be 3 times minus 3 is minus 9, plus 13 is positive 4. So this is your first pair. Now the annoying one is the second one, is the fraction. So when x is minus 24 over 5, we're going to have, that's not what I was looking for. We're going to have now y equals, let's try and do it fast here. So 3 times 24. What's 3 times, oh my god. So that should give us 72 over 5 plus 13. And to make your life easy, because there's no calculator, make 13 a fraction, so it's 13 over 1. Multiply up and down by 5 so you can add them. You should get 13 times 5 should give you 65 over 5. And yeah, now it's easy. So you have minus 72 plus 65, that gives you minus 7. So it's minus 7 over 5. So your two corresponding other two pairs would be minus 24 over 5 and this. Yeah, so always pair them together, yeah? So this would go with x equals minus 24 over 5. So two different solutions. All right, so yeah, so far so good. Alrighty, question 21. So ABCD is a quadrilateral, okay? AB equals CD, so let's write this down. So AB, this length, equals CD. And angle ABC equals angle BCD. Let's give them both the same letter X and X. Okay, so these two are equal. Angle ABC identical to angle BCD, and we can just call it X. Prove that AC equals BD. Alright, so first thing to know, yeah, these two AB and CD have the same length. Okay, so we can both call them L if you want for length. Now, the only way this can actually work is that we need to show that the diagonal AC over here and that these two are the same is by evaluating their triangles. Okay, that's the only way it will work. So let's work with ABC first. Yeah, triangle ABC. So something like that, L and X. Now, just by the rules of area of triangles or general triangle property, if we just call this length BC for a second, yeah, let's call it A. Okay. Since this angle is identical to this angle, we can clearly assume that the total area of this triangle and the length itself is going to be equal or identical is the correct word, or congruent to its reflected symmetrical triangle at the points BCD, where this is line L and this is angle X. This would therefore be A. So far the angles are identical. If the lengths are the same and the angle is the same, if we had to use the cosine rule, we will come to the conclusion that this final length, let's call it B, would also be the same. Okay, so hence both B's are the same. So we can simply state now that AC equals BD. So the lines, the long lengths, AC is equal to BD. Okay, that's really it. Yeah, straightforward. You could use the cosine rule, but you're pretty much done. It's a lot of marks. If you want to just guarantee all the marks, make sure you even repeat these lengths. You can say AB. I guess I could have also stated that AB here equals CD, and we defined it by the letter L, and that works perfectly. Okay, let's move on. Okay, final question, guys. 22. So this is ranked as one of the hardest questions apparently, but let's have a go and break it down so it looks, trust me, dead easy. So the diagram shows a hexagon A, B, C, D, E, F, okay? And they kind of look congruent or identical, probably. Now, A, B, E, F, so the left side and the right side of the shape are congruent parallelograms, where AB equals BC equals X. So, like it says, call them X. P is on the point AF, and Q is on the point CD, such that B to P and B to Q are 10 centimeters. So if you just draw a dot line that connects to P from B and a dot line that connects to Q, we have identical lengths of 10. Given that angle ABC is 30 degrees, so the whole thing, prove that you can make cos PBQ. So PBQ, between the triangle between PB and PBQ can look like this. All right, I'll tell you a very easy way. First things first, represent this as separate triangles, yeah? So I'm going to go ahead and draw two different triangles. The first triangle is going to be ABC with lengths X, X, and angle 30 degrees, because we know angle ABC is 30 degrees. So this means the only length we have here is AC. I'm also going to draw a second triangle, because again, always good to represent this properly. And I'm going to rename PBQ as alpha, just so it's easy to work with. So PBQ is alpha. So this is the angle alpha. And we know between alpha is 10 and 10. And we know that the length, using at least the long side, would be PQ. Now, when you begin like this, you can easily solve this now. Believe me, now we've solved it. One thing to note in this parallelogram is that because we know it's all congruent and for various reasons it should be equal, we can assume now that the length A to C is equal to length P to Q. So these two lengths are actually the same, AC and PQ. So in fact, you can go ahead and say they're the same. So we can say, therefore, AC equals PQ. Now, to resolve this, you got three lengths and an angle. Three lengths and angle. The only suitable formula from the top of my head is the cosine rule. So let's go ahead and use the cosine rule for the very first triangle, yeah? So I could say where, you could let AC be your little a, and angle be the capital A, I could say now, using the general formula with a squared equals b squared plus c squared minus 2bc cos A, that little a is ac squared. The little b and little c's are the x's. So x squared plus x squared minus 2 times x, which is 2x squared, cos 30. And the second equation for the other triangle will be the same thing, with PQ being the little a and alpha being the big A, and tens being the B and C's. So this will also give us PQ squared equals 10 squared plus 10 squared minus 2 times 10 times 10, which is 200, cos alpha. And there we go, guys. Here is our two equations we're going to work with. Okay? Now, because we know that these two AC and PQ are equal, so of course the squares will be equal too. This means that these two equations are equal to each other. Okay, so we can say now, so x squared plus x squared, so we can say that 2x squared minus 2x squared cos 30, we'll get to cos 30 in a second, must equal 10 squared plus 10 squared, so 100 plus 100, which is 200, minus 200 cos alpha. Okay, so not so bad. Looking back at the equation, they look like they just subtracted 200 somehow. Okay, so let's go ahead and do that, yeah? So subtract, okay, oh yeah, and let's firstly deal with cos 30. So to work out cos 30, if you don't remember the trig triangles, just draw your typical right angle triangle, label 130, and use the 1, 2, 3 rule. Suppose we call this angle length 1. This means that opposite, the hypotenuse will be 2. And using Pythagoras theorem, you'll get 3 but rooted. And we're done. So cos 30 is actually identical to, so yeah, cos 30, they use adjacent hypotenuse. So it'll be cos 30 equals the adjacent, which is root 3 over hypotenuse. So cos 30 is root 3 over 2. Now that actually helps us a lot. So let's go ahead and push this further, yeah? So we got 2x squared, so now we're almost done. So we have 2x squared minus, so if this is root 3 over 2, if you times it with 2, the 2 and the bottom 2 cancel out. You're left with root 3x squared equals 200 minus 200 cos alpha. Alright, almost done, guys, almost done. Now, to make your life easy, let's divide 200 across and factorize x squared here. So you're going to have 2 minus root 3 over 200 x squared. And now you're left with 1 minus cos alpha. And guess what, guys? This is practically it. Just switch the positions around, put cos alpha on the left side and this on the right side. And you will get, and I'm going to do this on the next page, cos alpha equals 1 minus all of that. And that's it, guys. I hope this idea helped. And just to keynote that, alpha, if you remember, was PBQ. Yeah, and that's it, guys. That's the end of the paper. And thank you for watching. This has been really honor, and I hope you guys enjoyed it. Let me know what you think. But other than that, I shall see you next time. Ciao.